All right, we made it to Magnaflow. Come check it out. All right, the development toys are out. We got Impalas, we got off-road trucks, we got a cool Falcon, and over here, Ford Shelby GT500. And we got Richard under a car, of course, where I always seem to find him.
How you doing, Kevin?
Richard Waitis, Director of R&D here at Magnaflow. Now, you guys are working on one of the coolest cars that I can imagine. What do you got going on today?
Yeah, GT500, supercharged, 500 horsepower. What can you say? It's a lot of fun. We actually just got her off the dyno. We've done some baseline work, got some acoustic work. We did some data logging. We're ready to kind of do some testing on some parts. Jose's just wrapping up the finished install of our 3-inch exhaust system, but we got some other work we're doing on here as well.
All right. I see you got some stuff over on the bench.
Yeah.
Actually, part of your development process?
One of the things that we do a lot of as well is our emissions control devices. It's the other part of the company that not a lot of people talk about, but
the tricky stuff, the not so simple. It's not just tubing. There's a lot of computers, there's emissions, there's, air resource board. All that stuff is the scary part from here forward, but that's easy for you, right?
Well, that's the stuff we've actually been doing for about 30 years now. So bringing all that together with the performance industry gives us the chance to really work from the engine all the way back to the tailpipe.
Cool. So this is what, the stock system here?
Yeah, actually, we've just taken the stock system out. We've done some baseline work. We actually did some analysis on the dyno to get what the tailpipe emissions are. We've created our 49-state legal part.
Cool. So this is a bolt-in. You meet all your emissions regs. Your O2s go right and your computer doesn't know the difference.
Absolutely. I mean, as you can see, we've kept the X pipe in place. So we've taken the factory design, incorporated our True X. It's a slightly more performance-oriented design that we've come up with. But at the same time, we've kept the packaging intact. You'll notice that the O2 sensors are in the same place to preserve the functionality. And we've got the same type of ceramic brick. It's slightly higher flowing, but at the same time, gives you the same functionality that you need to pass emissions.
Cool. And this is like, what, one step up from there?
Correct.
Performance-wise?
This would be our spun body cats. These are a metallic. They use a 300 CPI. Again, a little bit more flow. Supercharged car. We got a lot of airflow. Want to make sure that we can support the horsepower. But again, this is not an emissions legal part. This is one for the guy who still wants to maintain the cat, doesn't want to reprogram the car, but at the same time needs the extra flow and performance.
Cool. So you got an option for everyone. Now this is what, 2.5?
2.5. And actually...
And I thought I heard 3-inch?
Yeah, that's
so
exactly right.
So we got another one coming?
Yes, absolutely. We have 3-inch right here under the car. Jose's just wrapping up, putting the final touches on our prototype. As you can see, we've got everything tack welded. We're about ready to take this off over to our bender and bend out actually some of the components so we can actually do some finished testing. We've got the same spun body cats. You notice the O2 sensors are all intact and basically gone to the larger volume tubing. Again, we got a supercharged car here. A lot of these guys are going to try to add another 100 or 2 horsepower too.
Yeah, and that's going to help out a lot. And that's starting to look really good.
And when we get this thing to the end, you'll actually get to see what the actual differences are when we put it on the dyno. And at the same time, we'll do some emissions testing just to make sure we're still in compliance.
Cool. Now you're going to show me how to make some of this?
Yeah, let's go over here. We got our bender in the back corner.
All right. All right, I'm thinking we're reverse engineering here.
Yes. Basically, we've taken the pipe we just took off the GT500. We're scanning it in with the CMM so that we can get a digital model to do some bending or to play with the actual profile that we have in the computer.
Cool. This is a coordinate measuring machine. So you can basically, come in digitally, scan a part, and it'll basically make all the lengths, the rotation of bends, and the bend angles, and throw it in 3D, and now you can do all kinds of stuff with it.
Right. Actually, we're in so far that we can actually take this part, bend it out, and put it on the car right now. We look like we're ready to bend? Yeah, we're good to go. Let's take a look.
We got a killer mandrel bender over here. So, I mean, this will take and make tubing into perfect round bends. You're not going to get creases in it. And, because it's CNC, basically, you can repeat over and over again the exact profile of that tube.
Basically, with the mandrel, you'll see here, we're going to take and preserve that tube diameter throughout the whole pipe. We got some pretty big bends we're running here, but we want to make sure that the airflow is going to be constant throughout the whole tube from beginning to end. You'll actually watch this draw through, and you'll see that the pipe doesn't distort at all.
Cool. Now, there's actually a mandrel inside, and that's what's keeping that inside diameter perfectly round as you got the dies on the outside creating that bend.
We're actually able to recreate a part. Like you said, in mass production, we can do it hundreds of times, but exactly the same. This has got to fit into one of the fixtures that we're making, which we'll show you a little bit later, too, for every part to make sure every car fits the exact same.
Cool. And what's nice is you can have an immediate response. You can check if it on the car.
Right.
You can come back here and just change something a little bit. And this all happens before you even try to go to production.
Right. This takes out all the guesswork. Basically, when we say we have a finished part coming out of prototyping, this part could actually probably go in a box and get sold to our first consumer.
This is a lot faster than pre-bends, cutting, and welding.
Absolutely. As you can see here, we've got at least 5 bends that we're going to go through. Imagine taking that piece of pipe, cutting it, segmenting it, trying to fit it in a fixture, and then TIG welding it on top of it to keep the strength up. Well, looks like we're all wrapped up. We'll take this over there, get it on the dyno, and get some testing done.
All right, stick around. We got more coming at you. Hey, welcome back. Now we're at Magnaflow. We're in their dyno development section. I'm here with Richard Wadis. Now we just finished pre-bending, pre-production type parts.
Yes, we did.
We could check all our, our part fitment, how the assembly works. We could see how well we did in that category. But now we get to see how it sounds and what kind of power we get to make.
Absolutely. We just got her strapped into the Dynojet dyno. We're going to do some rear wheel horsepower and torque measurements. And at the same time, we're going to do some data logging here, so we actually get a sample of what the sound characteristics are with our spectrum analyzer. Sounds like everything's ready to run here, so we're ready to go.
All right, fire it up. That sounded awesome.
Sounds one thing, power is the other thing, and there's that graph.
Ooh, nice big jump all across the power band.
The combination of the X, the high flow cats, the full 3-inch exhaust system, and the supercharged motor. It's just a really happy setup for the car, it looks like.
It really makes a difference. You can see on the power, but the sound is just so much better. You get to enjoy a little bit more of it coming through the windows, and everybody else gets a little enjoyment too, right?
Yeah, indeed. And that's an important part too. Actually, we look at is not only what's happening outside the car, but what's happening inside.
Oh yeah, a lot of different frequencies in there. Resonance that can get really a bad vibe going on at certain speeds or loads. So it's kind of critical. You've got basically a baby grand piano under the hood, but you don't want your 3-year-old just banging on the keys, right? You want Mozart playing that music right out the tailpipe.
Absolutely. And that's still only about half of what we do here. We have a good deal of information that we've got to acquire, not only from this dyno, but our Mustang dyno. But we've got to do all the data acquisitions for all the engine management control systems to make sure that the power we make is not accidental. It's really something that's a function of the parts that we changed.
Right.
So we can sit there and watch your air-fuel ratios. We can monitor the timing values to see really where that power came from. And ultimately, it translates into what we have to do for our emissions program and seeing what's coming out that tailpipe to make sure we're clean.
Yeah, it's not a hack and slash. I mean, this is a pretty delicate operation. You want to make sure it's right from start to finish. So.
Absolutely.
All right, well, let's go see how we make more of these parts. We got all the prototyping. Let's check out the other end.
Let's go check out those fixtures.
All right, welcome back. Now, we're at Magnaflow. We're in their R&D facility. Now, on the other side of the curtain, we were able to make parts, test fit them, actually put them on the dyno, test everything out. Now, on this side of the curtain, we get to put stuff partway into production, right?
Absolutely. This is the last phase of our prototyping experience, so to say. We've got to take the part that we've made one of and now make 100, maybe 1,000 of these parts, depending upon what consumer demand is. We have to make a fixture that can control each and every vector that we've actually placed on that car to make sure it's going to fit not only the one that we built, but every one thereafter.
So you can see that part's not going to move, and you're not just checking here, right? This is how you're building that part.
Right. That's one of the unique parts about what we actually do here is that we're making a build fixture, not a check fixture. 100% of the parts that go through are actually being quote-unquote QC inspected because they're actually built in the one reference item that we are making. This is another unique fixture that we have. It's got the unusual saddle underneath the catalytic converter. In the market that we're in, we have to build parts for 49 state and California, and sometimes they really offer us a challenge in that they're going to give us different specifications. A bigger brick for California, a smaller one for 49 state. So by making some of these parts interchangeable, we can actually consolidate the number of fixtures we have because really, quite honestly, with all the applications we cover, we're looking at tens of thousands of fixtures to supply our complete product line.
Now you guys cover not just the hot rod end of stuff. I mean, you've got BMWs, you've got Acuras. Seems like you cover just about the whole spectrum.
Absolutely. We're a full-line exhaust provider. We cover everything from A to Z as far as automobiles. We cover catalytic converters, the performance exhaust, and even some of the replacements in our muffler series.
Nice. Well, this picture looks like it's just about ready to go.
Yeah, it's got all the controls in place. It's got all the clamps there. Literally, this part can be turned upside down and backwards in our robot and still not lose any of the vector points. We're going to get a part that fits.
Now, these are going over to your production plant?
Absolutely, and that's what we're going to take a look at next.
All right, well, we're running out of time here. We're going to take a break. We're going to see the magic of how this turns into a lot of exhaust systems for you to pick from. Stick around. All right, well, these guys are getting bigger, and they got a brand new facility, so we're here to check it out. And as always, it starts from raw material. These guys are making everything in the States right here in California, and you got to ask yourself, how do you do business in the States anymore? You get smarter.
Got everything from the coils to make the basic things of the bodies, the stampings that we have for our catalytic converter line, all the way up until the coils that we use for making our mufflers.
You're not worried about can you get the material, what shape does it come into you at. There it is. You guys make it all the way to the end.
Absolutely. The first thing we're going to pass here on the left, you're going to see is our basic stamping department. Here we have all our presses. This is where you see all those proprietary collector designs that we've come up with. All start off as raw material going through these machines.
Now this machine over here, this is looks like we're starting with a sheet. We're rolling it in.
That same concept. We're taking the basic raw material, the coil, and this is our muffler machine. Basically, this will take what we have is a raw piece of stainless steel, run through, actually stamp our name into it, shear it to the right length, form it into the actual either oval, round, or whatever shape necessary, laser seam weld it, and pop out the other side what looks like pretty much a muffler without ends.
All right, so we had like a roll of tape over there out of stainless steel, and now we got cool tubes we can start making catalyst bodies out of?
Absolutely, and as you can see, the seam weld is all laser controlled. You get a nice even weld, the penetration is very good, and it actually allows for a surface that we can manipulate like in the spinning machine or even in other options that we have.
Cool. What's cool is it looks good on both sides, and I see over here you guys got ovals. This comes out of the same machine?
Same machine can do the same thing. If you want an oval shape, the small 4x9, our 5x8, or even our 5x11s, we're capable of doing any size we want and having the same effect.
Now we got our tube, seam welded, we've stuffed it with our catalyst brick. Now Richard's somehow going to magically show us how they form it into something completely different.
And this is what we're looking at here, is basically this machine is capable of taking that end form and creating what we have here in the finished product. It actually rolls all the edges and extrudes the end out until you actually get what started off as a 16 gauge piece of material to something that's actually much thicker and much stronger.
All right, Brian, get your hammer and dolly out. Let me see you make something like that. This is actually a pretty cool looking part.
These are our muffler internals, and you'll see a little bit of what we got. We got the steel wool packing. That's there to actually protect the acoustic packing material that we put around it. We will take this part here and actually put the acoustic packing material around it, stuff it, and actually shove it into the body that we just rolled at the other machine.
Okay. All right, so I see we got maybe a stuffer here, and it looks like an assembly line, and then what are we feeding in there? I see a lot of things going on.
This is the big fun machine. This is where you can actually watch the part that looks almost like a muffler go from something that's a bunch of assembled parts to the part that you open the box and see, which is completely welded on all sides, including the body and the actual nipples that go into it.
Cool. So on the other side of there, I got a finished muffler?
Absolutely.
All right, this kind of fixture looks pretty familiar.
Yep, this is exactly what we got out of prototyping earlier today and what we send to production so that they can actually do what we're seeing here. Take that muffler we just saw built on that machine and now start fitting the pipes to it to get the finished assemblies. You'll see we'll do the same mandrel bending just like we did in prototyping, but here we're actually going to set everything up for finished welding. So once the mandrel bending's done, we actually take it in this cell and it goes through its trimming operation so we can cut it down to the right size for the fixture and then actually finish off with all the proper end forming that goes on.
Nice, so you can keep everything within a good working cell.
Right, in here we can actually work with much smaller build quantities at the same time have just as many finished goods come out the door all finished. And this is where everything gets stored. Look at our footprint, multiply it by how many racks tall we got. You could easily say we're close to 500,000 square foot of storage.
Wow, that's a lot of cool stuff. Richard, tell me what's going on with this sort of Space Ghost power band. I mean, does it have lasers? Does it shoot down aircraft? I mean...
Not quite. It's this animal we got right here. Basically, it allows you to scan and actually see what the product is that the guys are picking on the floor as to what's being ordered on the sheet up front. This allows us to control and make sure, obviously, the right product's getting down the right lane.
Okay, so it's like a mainframe brain, and it's like just pumping right down into this wristband?
Not quite, but it does allow the communication to make sure that we are getting the right information back and forth. If we're sending 100 at a time, it better be the 100 right ones.
Hey Mario, you think this will work on our 2011 Mustang project? Yeah? I think I'll grab one.
What are you doing?
I was getting my 2011 Mustang.
Oh, come on, no. This is not 2011 Mustang material.
No.
If you need 2011, we got 2011 for you. We got a complete system we're in the works with.
You're gonna ship it to our shop?
If you need it at the shop, we'll have it there.
All right, sounds like a plan.
Awesome.
Richard, thanks for showing us around.
No
Hope
problem.
you enjoyed today at Magnaflow. Check us back at our shop for a 2011 Mustang build.